Hello again. We are continuing our discussion of graphing quadratic functions by talking about the transformations that can happen with quadratic functions. So let's get started. We're going to summarize the transformations that we've talked about before. Here's the parent function. It's y equals x squared. If I add k to that function, then the whole graph is going to move up by k spaces. If instead I subtract k from the function, that means that the whole graph is going to move down k spaces. All right. Now, if I subtract a number h inside the parentheses before I square that number, that means that the whole graph is going to move right h spaces, whatever that number is. And then instead, if I add h inside the parentheses, the graph is going to move left. Now, those two things are the opposite of what you would think they would be, but you just have to remember that that's what those transformations are. If I multiply the entire function by some constant a, then the graph is going to stretch by that amount if a is greater than 1. And then if a is between 0 and 1, that means that the graph is actually going to be compressed by that fraction. All right, and then if I multiply by a negative, that means that the entire graph is going to flip over the x-axis. So that's a summary of the transformations that can happen. So here's an example. If I have negative 2 times x plus 5 squared plus 8, okay, I start with the parent function, which is x squared, and I need to get to that new purple function right there. Well, what's happening? That plus 5 that's in parentheses means that the entire graph moves 5 spaces to the left, and the vertex goes with it, which is now at negative 5 and 0. Okay? Then I look at the negative, which reflects the graph over the x-axis, but the vertex really hasn't changed because it's on the x-axis. Okay? The 2 is going to stretch everything, so it's twice as far from the x-axis as it was before, but the vertex, since it's on the x-axis, is not going to move. And then the plus 8, the very last transformation, means the entire graph moves up 8 spaces, and now the vertex has moved up 8. So we are now at negative 5, 8. That's where our vertex is now after all of those transformations. All right, so let's look again and summarize what happens to the vertex, because this is going to be very important for a future lesson. When I start, it's at 0, 0, and then when I move 5 spaces to the left, it's now at negative 5, 0. But when I reflect over the x-axis, it doesn't change, and when I vertically stretch it by 2, it doesn't change. When I move 8 spaces up, that's when it changes. All right, so now the vertex is at negative 5 and 8. And I want you to look at those two numbers, negative 5 and 8, and I want you to look back at the purple equation that I was actually graphing. The negative 5 is actually the opposite of the number that's in the parentheses, and that will always be the case. And the 8 is the same as the number that is at the very end, and that will always be that way. So just a pattern to point out so that you can save some time when you're graphing these parabolas. All right, if you have any questions about this, please let me know, and I will see you tomorrow.